Welcome to Math 119, Chapter 2.3, 2.4, and 3.2, where we talk all about intercepts, slopes, and lines, and how to graph lines. You'll notice that there are a few sections here kind of all done together. That is because they flow really nicely one into another. For your Hawks Learning homework, Chapter 3.2 is not going to be for homework because 2.3 and 2.4 have bits of 3.2 in it. So really, Hawks Learning, you do not need to do the 3.2 homework listed. Now, first thing I want you to do is that warm up where it says graph the line below and answer the questions. So you'll notice you have y equals 7/2x minus 2. So go ahead, answer the question and see if you can go ahead and graph by pausing the video. So before graphing, what are the two given information that is given from the equation above? Well, above, before you can graph, you must recognize that your slope, m, is 7/2. Now, what does that do for us, right? Well, the 7 tells us we are going to be going up 7, and the 2 is going to say we're going to go over by 2 units. So up 7 and over 2 units. Now, that's great, but then if that takes care of this one, because this is in slope intercept form, y equals mx plus b, where m is considered that slope and b is considered what? This is your slope. B is considered your y-intercept. Your y-intercept, when x is equal to 0, you have b remaining. So that just means here, -2 is your y-intercept. So we're going to be starting at 0, -2. Now, if you don't know the structure of this line, that is something that will come up more later on in this video. So if that's where you're kind of starting, then that's understandable. But otherwise, kind of hang tight. So -2 is our starting point. So, and y is equal to -2. We said your slope, we're going to go up 7. So 1, 2, 3, 4, 5, 6, 7. Okay, we're going to go up 7. Then we're going to go over 2. And there you're going to have your very next point. And you can do it again if you need to. So again, going up 7, 1, 2, 3, 4, 5, 6, 7 kind of goes off the page, and then you go over by 2. So something like here. And if you wanted to go to the other side as well, you just have to go down 7 instead of up. So 1, 2, 3, 4, 5. Oh, it's counted. 1, 2, 3, 4, 5, 6, 7. And then over 2, 1, 2. That would be your next point. Don't forget to connect the dots, which I'll try my very best to do on this iPad. There we go. So you'll notice I'm a little off on the one that's on the page, or off the page. And there you have the line, y equals 7/2x minus 2. So now see if you can graph the questions 2, 3, and 6 on the graphing lines worksheet at the back of this page, labeling your slope and your y-intercept of each. So that page looks like this one. So just graphing these lines, you'll notice that we just graphed the first 2. See if you can graph the remaining. Now the slope of a line, actually, let's see, 2, 3, and 6. We'll do 2, 3, and 6 together. Okay. So you'll notice that we've done this first one already. Now we're going to just do numbers 2, 3, and 6. If you want to do more, please feel free to do more. So again, your slope is -6, and pause the video at any point in time. So we're gonna go down 6 and over 1. So the reason why we're gonna go down is because of this negative. Again, stay tuned for why that is if you're a little rusty on this stuff. So we're gonna go down 2, and then we're gonna go over by 1. Now we're going to be starting at your y-intercept of 3, 0. So this is your starting place. So at 3, 0, we're starting here. We said we're going to be going down by 6. 1, 2, 3, 4, 5, 6, and then over 1. So down 6, over 1. That is our next point here. And we're just going to go ahead and connect the dots as best we can. Sometimes it's hard to connect dots on this. This one being so steep. There we go. There's your line. Okay, so let's try it again for number 3. So we have y equals -5. So where is y equal to -5? Try and locate that on your graph. Where's y equal to -5? Well, y is equal to -5 here at the point 0, -5. Where else is y equal to -5? Well, y is equal to -5 right here at 2, -5. Anywhere else? Maybe here, maybe here, maybe here, right? Now, what kind of line is this forming? Well, this is forming a horizontal line. So even when you don't have your slope, which in our case, we're going to learn what your slope is of these horizontal lines and why it is in a moment. But this is the line y is equal to -5. Your y stays constant at -5, no matter where you are on your point. -3, -5, -5, -5, 4, -5. Notice that your y value is not changing, but what is changing is your x value. But it doesn't matter what your x value is. They only care about your y value. Now, very similarly, try to figure out where x is equal to 5. Well, x is equal to 5 here at the point 5, 0, right? We just need your x to be 5, but where else? Well, we can have one here at 5, 1. Again, maybe over here and here at 5, 4, at 5, -3. What kind of line is this one forming? This one is forming a vertical line. So again, if not much is given, but you know that x is equal to something, we can understand that your x value is going to be constant this time, and it's your y value that is going to be changing. Now your other ones, if you were to graph them, again, we're just starting at your y-intercept. This time we're going to go up 6, 1, 2, 3, 4, 5, 6, and over 5, 1, 2, 3, 4, 5. Now, if that goes off the page, then maybe you go in reverse. Instead, go down 6, 1, 2, 3, 4, 5. Oops. 1, 2, 3, 4, 5. There we go. Oh, 6. And then over 5. 1, 2, 3, 4. Connect your dots as best as you can. And there's your line. One more time, starting at 2, going up 1 and over 4. Or in the reverse, go down 1 and over 4. There you go. So these are all types of your lines. Right, now let's focus in on the slope of your line. Your slope is referred to as your rise over your run, right? We talked about this value, we're either going up or down. And then the bottom one, we're going over. Now this comes from the change in your Y value. So rise, we're talking about the change in Y. So excuse me. Sorry. The change in Y over the change in your X value. Now it's a little misleading when we talk about rise because we can also change your rise by falling. So rise doesn't just mean we're going to be increasing, but it also tells us that we can actually have your Y value decreasing as well. And this is going to be over any 2 points. So as long as you have 2 points, you can figure out the slope of a line. Now below we have the different orientations of lines. So we can have positive lines or positive slopes, negative slopes, a zero slope, and no slope. Now, what causes these slopes to be zero? Well, keep in mind, we're talking about slope being the change in your Y over the change in your X. So what causes your slope to be equal to zero? Well, in order for that to happen, we said, well, over here, right? If our structure was Y is equal to mx plus b, and if we have your slope to be 0, x plus b, or y equals x plus b, so then y is equal to what? Well, y is equal to b. What does b stand for? It's your y-intercept. Now, the reason why we can say it's equal to 0 is because no matter what, where on your graph, your y value, is it changing? No, just like the last time when we said y is equal to, I want to say it was positive 5. Or no, this one was negative 5 in our last one, right? Well, I guess for this purpose, we'll call it just positive 5, right? No matter what your coordinate is, your y value is the exact same. Your x value is the one that's changing. Maybe it's negative 5, negative 3, 0, 1, 2, 5, who knows, right? But your y value is constant. It's not changing. Therefore, if there's no change, it's 0. So 0 over the change in x, which is happening, is going to be 0. So then what causes no slope? Again, your slope is equal to the change in y over the change in x. So let's just say, again, this is when x is equal to 2. So no matter where on your graph we are, x is going to be equal to 2. So your x values stay the same. So in other words, there is no change in x, while there is some sort of change in your y. Which means if there's 0 in your denominator, is that allowed? No, so we're undefined. No slope. So now what if we are not given the form y equals mx plus b, which is known as your slope, intercept form? Your slope and your intercept form. So what if it's not in slope intercept form? So for example, 4x plus 5 is equal to 20. Can you graph using the slope intercept form? So one thing we can do, since it's not in slope intercept, this is a general form or standard form. We have 4x plus 5y is equal to 20. How can we make it to have the structure y equals mx plus b? Well, simple answer is y is isolated and all alone. So try and pause the video to get y here to be all alone. we can subtract 4 to the other side, 4x to the other side, and then divide by 5. Y is equal to negative 4x over 5 plus 4. Now, can you graph this line? So again, go ahead, pause the video, try and graph your line. We're starting here at 4. And then our line, are we going to be increasing or decreasing? We're going to be decreasing because ours is negative. So we're going to be going down 4 and over 5. So down 4 and over 5. Oops, too far over. So your very next point is over here. So graphing using your slope intercept form, we just need your slope and your intercept, your y-intercept, that is. All right, so now let's graph using your intercepts. So keeping it in this form, 4x plus 5y is equal to 20. So what is an intercept? Well, an intercept is anytime your graph touches the axis. So if we're looking for your x-axis here, if we're trying to touch your x-axis, this is where your y is equal to 0. So for your x-intercept, so now let's graph using your intercept. So if we have the form 4x plus 5y is equal to 20, what we're going to do is figure out, well, what is an x and y intercept? Well, an intercept is where your graph or your line touches these axes. So if we're looking for your x-axis to start, your x-intercept to start, right? That's where your line touches your graph or your x-intercept. X-axis, I cannot talk today, I'm so sorry. So this is when your y is equal to 0. So to find your x-intercept in this form, we're going to set y equal to 0. So we have 4x plus 5 times 0 is equal to 20. So you have 4x is equal to 20 and x is equal to 5. So this is your x-intercept of 5, 0. And if we did the same thing, but for your y-intercept, this is anytime your graph touches the y-axis when x is equal to 0. So instead of having y set equal to 0, we're going to set x equal to 0. So 4 times 0 plus 5x is, 5y is equal to 20. 5y is equal to 20. Y is equal to 4. So 4, comma, 0, comma 4. 0 coming from, hey, this is your x coordinate. So when we're talking about graphing using your intercepts, you're going to put your points down first and then go ahead and connect the dots. There's no need for your slopes if you're just using your intercepts to graph. And to kind of reiterate what these intercepts are, an intercept is where the graph touches the x and y axis. To find the x-intercept, we substitute a 0 for the y coordinate. And to find the y-intercept, we can substitute 0 for the x coordinate. So now let's practice graphing the intercepts on question 2, 3, and 4 on your graphs by converting, I read that wrong. Practice using graphing by your intercepts on questions 2 and 3. And then on question 4, graph by converting into slope-intercept form. So you'll notice we just did this first one. So let's take a look over here. So we are going to be using your intercepts to graph. Now, just in case, I'm going to have you pause the video and try 2 and 3 using your intercepts, and then 4, you're going to convert into slope-intercept form and graph that way. All right, so your x-intercept is where y is equal to 0. So you have 2x plus 0 is equal to 2. So 2x is equal to 2. So x is equal to 1. So we have the coordinate 1, 0. We can plot that right here. And your y-intercept is when x is equal to 0. 2 times 0 plus y is equal to 2. So y is equal to 2. So we are going to plot 0, 2 on your next one. So plotting your intercepts, you just need those 2 intercepts and then the line that connects them. Let's do it again for number 3. Again, your x-intercept, we're putting y to 0. 2x minus 0 is equal to negative 4. 2x is equal to negative 4, so x is equal to negative 2. So we can plot the point negative 2, 0. Let's do it again for your y-intercept by plotting or plugging in x for 0. 2 times 0 minus y is equal to negative 4. So y is equal to negative 4. Therefore, y is equal to 4. So we're going to plot 0, 4. Way up here. So again, we just need those 2, the line that connects them, and that's it. And you'll notice that I go beyond the line or the points and then an arrow. That's just to say this line is continuous rather than just making a line segment. Now, number 4, we're going to have you convert into slope-intercept form so that y equals mx plus b form, and plot your graph using your slope and your y-intercept. So if we rewrite it over here, let's add subtract x to both sides. Negative 2y is equal to negative 8, or negative x plus 8. Dividing by negative 2. So you're left with y is equal to positive 1/2 x minus 4. So where are we starting? Well, we're starting at your y-intercept of negative 4. And our graph, or our slope, tells us we're going to go up 1 and over 2. And if we wanted to do more, we certainly can. So going up 1 more and over 2, you can keep going and plotting as many points as you want, as long as you connect the dots in the end. And there you go. Notice that you didn't end up plotting your y or your x-intercept this way. You're just looking at your starting point and then your slope. So now let's take a look at your slope-intercept form and your standard equation. So your standard form has ax plus by is equal to c. Now in this form, your your x and y intercepts are easy to figure out. So find x and y intercepts easily. This one you're provided with, you find your slope and your y-intercept easily. So sometimes if they're saying, hey, find the intercepts, and if it's already in this form, that's great. You don't have to convert it into this form unless it tells you to after. But you can certainly still find your x and y-intercept in this form just by, again, substituting a 0 in for your variables. Now, what happens if we're given the line itself and told to find the equation? So pause the video, see what you can do from the first one on the left and again on the right. Well, the first thing we want to notice, right, if we're talking about slope-intercept form, y equals mx plus b, that's a lot easier to do than trying to figure out ax plus by is equal to c. This is going to be really challenging, even though you can see you have your y-intercept and your x-intercept. Sometimes your x-intercept isn't going to look beautiful. Same thing with your y, right? So let's try and figure out what your y equals mx plus b equation would be. So in our case, what is b? Well, b is 4, your y-intercept. So then how do you find your slope? Your slope comes from figuring out what the next closest point is. The point where, well, all of these are points on the line, the best point is anywhere your line meets directly in the corner of these boxes. So you'll notice that the next one here should be at 2, 1. Now we don't need that point. What we do need is how to get from point to point, how to get from one point to another. Well, we go down by how many? 1, 2, 3. So we went down 3 and over 1, 2. So how does that translate into your slope? Well, we went down 3, so that must mean we have a negative 3 over 2. So then what does that mean for your equation? So your equation, y equals mx plus b, your m we already found, x plus b your slope, or sorry, b your y-intercept. Now try it again here. Your b is 2. Your slope, the very next best point could be right here. So from point to point, you went 1, 2, well, actually, well, we are going down. Your graph is rising, so you're going to have a positive slope no matter what. So maybe you want to label plus, but the difference between these points, let's see, if we want to go over 1, 2, so over 2, and up 1, 2, 3, 4, 5, 6. So 2 over, hold on, that doesn't match. One, 2, 3, 4, 5, 6. Oh, I see what I did. So in this one, right, we're trying to find your y-intercept. So that's the first thing we want to see. Your y-intercept is 2, and finding your next best point. Now, your next best point perhaps is this one. Now, if you didn't see it, but maybe you saw this one, you'll notice that some of your points, if you're not picking the next closest point, we might figure out that we have to reduce. So if your slope reduces at all, that's where it would happen. And to go to point, whether you go over 1 and up 1, 2, 3, right? So 3 over 1. To go in reverse, like if you went from this point to this point, you might be tempted to say, well, we went down 3, but keep in mind your slope is rising, your graph is rising, so your slope is going to be positive. So again, we go from 1, 2, 3 over 1 and 1, 2, 3 over 1. There we go. So again, y equals 3x plus 2. So essentially what we have done on these two problems is that we are given only 2 points and we are asked to create an equation from the graph itself. But let's say we take away your graph, but you're still given 2 points. So how do you create the equation for the line? Well, the first thing to know is the slope. Slope has an equation, y2 minus y1 over x2 minus x1, the change in your y over the change in your x. Now, y2, y1, x2, x1, these are just points given to us at the very beginning of the problem. So for example 1, let's have you find the slope of a line through these 2 points. So pause the video and try them yourself. So if we're trying to find your slope, and we know it's y2 minus y1 over x2 minus x1, go ahead and first just label x1, y1 as your first point and x2, y2 as your second. Now, it doesn't matter which one you label as x1, y1, as long as they come as a pair. So don't mix and match. It doesn't matter the order, just as long as these are together. So let's see, y2 we have labeled as -5 minus y1 is a -3, so use your parentheses, over 2 minus a -4. Now that double negative is going to make a positive, so we really have a +3 and a +4. So we have -5 plus 3, that is -2, over 2 plus 4, that should be 6. So we really have -1/3, so sorry. So that is your slope of the equation. So if that's all you needed for that one, try it again for part B if you have not paused the video already. All right, so for our next one, we're working with fractions, which that's okay. Again, all you're gonna do is just label. So we have y2 as -4/3 minus 1 divided by 1 minus 3/2. Now, working with fractions, we want to make sure we get a common denominator. So if you wanted to set this over 1, your common denominator would be 3. So we have 3/3. And again, 2/2 minus 3/2. So we get -7/3 divided by -1/2. And you have a fraction over a fraction, so we're going to keep change flip. -7/3 times -2/1 to make 14/3. So it's always a good idea to just check your work. So making sure that we put these in correctly. So making sure your signs are there. Same thing over here, 1 and 3/2. Looking at a common denominator, 3, 3, 2, 2, all looks good. Now let's say in example 2, using the slope in part A that we have created, can you find the equation of the line? So your slope being -1/3, right? Well, what's missing? Because your equation needs to be y equals mx plus b. So what is missing? Well, you're missing, if we were to plug it in, you're missing your b. However, we are given your 2 points. You are given -4 and -3, and 2 and -5. Now these are coordinates. These are x and y's, very similar, if not the exact same, to your x values here and your y values here. So what we can do, because what we don't have is your b, but we do have your x and your y, we can go ahead and put them in. And now it doesn't matter which point you choose any point. choose any point. I might choose negative, no, I'll choose 2 comma negative 5. So if we have negative 5 equals negative 1/3 times 2 plus b. So then we have negative 5 is equal to negative 2/3 plus b. I can add 2/3 to the other side. So b is equal to 2/3 minus 5/1. Common denominator, 2/3 minus 15/3, and you'll get 13/3. So this is just your b. So then when we go back and substitute it back in, we really have 13/3. Actually, it's a negative 13/3. Just checking my work. Sometimes I leave off my negatives, even though they are super important. Now your last form, instead of choosing your slope-intercept form, students may want to use point-slope form. So if slope-intercept form gives you your slope and your intercept, point-slope form gives you your point and your slope. So let's find an equation of the line that passes through the point 1, -3 with the slope of -1/2. However, your answer should be placed into slope-intercept form. So if you liked what we did before, you can 100% pause the video and try it out with that method. Otherwise, you can try it with the point-slope form. So point-slope form, this is really your x1 and this is your y1. So if we're replacing your variables with what we have, you have your y1, you have your x1, and you have your slope. So let's go ahead and substitute those in. We have y minus a -3 is equal to -1/2 x minus 1. So we have a +3, -1/2 x minus 1. And now we need to convert into y equals mx plus b. So we can do this by first distributing in. And if you can, I would encourage pausing the video and trying it yourself. So distributing your -1/2 throughout to make a +1/2. Subtracting your 3. Finding a common denominator. So your final answer should be y equals -1/2 x minus, let's see, 5/2. Now we can again shortcut that if you liked what we did from the last time. You have your slope, you have your point, you have your y equals mx plus b setup. So we just substitute what we are given. So you have y, oops, that's your x value. So you have y, you have your x, you have your slope, and we get to work that in. So you have -3 is equal to -1/2 times 1 plus b. -3 is equal to -1/2 plus b. So b is equal to -3 plus 1/2. Common denominator, we already said this is going to be 6/2 plus 1/2. So -5/2. So notice that this kind of negates having to distribute and pull things over, but it'll come up with the same exact answer. Y is equal to -1/2 x minus 5/2. So please, 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 I don't care which way you do it, just pick a way and get really good at it. So let's look at example 4, our final example. Find the equation of a line that goes through the points -3, -2, and 1, 6. So pause the video, kind of go from start to finish. So the very first thing we need to find is your slope. So you don't have your slope, so we need to go find your slope. 6 plus 2, 1 plus 3. So we're working with 8 over 4 or 2. So that's your slope. So number 1 is to find slope. Number 2, once you find your slope, choose your method. I'm a huge fan of this one, so I'm going to stick with that one. Now, if you're between 2 points, it doesn't matter which point you want, which point you choose, you just have to choose one. So we know your slope, we just choose a point. And that goes for both variations. If you're using point slope or slope intercept, just choose whichever point you want. I might choose 1 and 6. And I'm going to work it into slope intercept form. So I have 6 is equal to 2 times 1 plus b. So this 2 being your slope, this 6 being your, this 1 being your x, and this 6 being your y. We're solving for b. So b is equal to 4. So y equals 2x plus 4. And there you go. So in summary, we do have different forms of linear equations. They are all used for different things or have uses for different things. Standard form, ax plus by is equal to c, is used for quick calculations for your x and y intercepts. Slope intercept form, y equals mx plus b, is really easy if you're just looking for your slope and your y intercept. And your point slope form equation is when your y-intercept is unknown, and it's easy to convert between the two forms. And there you have it.